Hello, good morning, everyone. In this video, I'm going to give you a hints on chapter 28, programming projects. Please note that the programming projects are due November 8th. So let's look at this first programming project. So this is to test whether a graph is connected. So here we're going to get the description of the exercise from this site. So I'm going to copy and paste and see it here. All right, we have to open the Word doc. So I'm going to open it now. And I'm going to reshare the screen. So I'm going to stop sharing and reshare the Word file. All right, so this is the Word file to describe chapter 28, programming project 1. So here, and this is the class name, exercise 28_20. Write a program that reads a graph from the console and determines whether the graph is connected. First line in the input contains a number that indicates the number of vertices. So here, this is the input, and this is 6, means 6 vertices. The vertices are labeled as 0, 1, and 2, n-1. So this is 0 to 5 for 6 vertices. Each subsequent line with the format U, V1, V2, so that means an edge from U to U1 and to U to U2. So here, this is the figure right here and gives this 2 examples for 2 graphs. So this is 6 vertices and 0, 1, 2. So 0, 1, 0, 2. And for 1, you have 1 is from 1, 0 and 1, 3. So this is right here, the second line. And for this graph here, 6 vertices, and 0 has 1, 2, 3. So this for 1 is 1 to 0 and 1 to 3. Your program should prompt the user to enter the input, create an instance G of graph, and invoke g.printEdges to display all the edges, and invoke DFS to obtain an instance tree of the tree class. Okay. This is the should be the search tree. If tree dot get number of vertices, get number vertices font is the same as the number of vertices in the graph is connected. So we're gonna have this, get this search tree. If the number of vertices in the search tree is the same as number of vertices in the graph is connected. So I'm gonna read the input using next line as a string. So here, this is the, just emphasize, you need to use the next line. And so to read everything, to be consistent, we use the line input as a string and then extract the string into integers. Don't use token-based input such as next int. Token-based input cannot be mixed with line-based input. Use and this template to test your code. All right, so here's a sample run. And so here's enter the number of vertices. And so here's enter 6. The number of vertices is 6. Enter the edges. So here you enter all these edges. So here's the input 6 and all this the rest. So you get the graph, and then apply the depth first search. And so you look get the number of vertices. It's the same as the number of vertices in graph. The graph is connected. All right. So here we're going to have, this is another sample run here, and the graph is not connected. Okay. All right, so let's take a look at the this one right here is the template. So I'm going to the template. Okay, I'm going to do this now. Reshare this. I'm going to reshare this right here. Oh, so I'm going to reshare. All right, so this is the test code you need to write. The things you need to write here is in this main method. So you're going to write your code to get the input. From the input, you're going to create the graph, and you apply the depth first search, and you get the number of vertices in the search. And if it's the same as the number of vertices in the graph, and the graph is connected, otherwise it's not connected. So here, those are the things just copy from the book. So here's unweighted graph class, and then you have the interface for this graph. So this is everything just copied from the book. All right, so you can write your code right here. Okay, I'm going to give you a little bit more hint here. So let's go down to this right here. Yes. Okay, I'm going to put this the main method right here. So you're going to write your code right here. So the first thing is you're going to read the number of vertices. So that's like a 6. This is the number of vertices in the sample graph. So you're going to use it. You're going to read it using next line to read it, and then convert this next line to integer. Okay. All right. So And next, you can read the you're gonna create we're gonna read all the ages. So you're gonna read all these ages. You can do this, some things like this, read all the ages, read all ages. Okay, so you can have something like a list. So java.util dot list of the ages. So there's one thing here is I think we need to do is we need to look at this. When you look at this, yeah, so we have this age here. Age is given here. So this is the age right here. So age is already here. All right, so we're gonna go to this list of these ages. So we're gonna create this list as new java.util and dot array list brackets. Okay, so now you're gonna read all these lines. So you and form an age and put it and creating this is the age objects and put it into this list. Okay, so now read all ages and into list. Okay, read all ages. So you're creating age objects. Create age objects and store it into list. Okay. All right, after this, you read all the ages. And now you're creating a graph. Create a graph G, unweighted graph G. So what you need to do is now you need to, after this, you're gonna print all the edges. So print all the edges. And now, and test if G is connected. So how do you test the G is connected? And you need to get the this is the unweighted graph. So here is unweighted graph with this integer as the all the vertices as labeled as integers, and that I think this is search tree. So you get this search tree here from G dot DFS, starting from you can start from the any vertex. Let's start from 0, and now just see if the number of vertices this tree, and see if tree dot okay, see if tree dot get number of vertices is same as the graph size, number of vertices. So if this is true, and the graph is connected, otherwise it's not connected. All right, so that is all the hint for this exercise. Okay. All right, I'm gonna copy and paste somewhere here. All right, so let's look at the next programming project. The next one, so here's the next one here. To find path. Define a new class named unweighted graph with getPath that extends unweighted graph with a new method for finding a path between two vertices of the with the following header. So here's a get path. So this is u to v, the index of the vertices, and you get the return is a list of integers. The method returns this list of integers that contains all vertices in a path from v to u in this order, using the breadth first search. You can obtain the shortest path from u to v. If there isn't a path from u to v, the method returns null. Write a test program that creates a graph for figure 28.1. So the figure 28.1 is the map. So with the Seattle, San Francisco, Chicago, Denver, all this on the map. The program prompts the user to enter two cities and display their path. So here's a sample run. Enter a starting city, Seattle. Enter an ending city, Miami. The path is Seattle, Denver, Kansas City, Atlanta, Miami. So if you use the code from the book, you're gonna get this unique path. So this is the path we'll match this here. So we're gonna use the template from the book. So we're gonna look at the template now. So here is the template. All right, so we use the one from the book. Here is the vertices, and this are the edges, and we created the unweighted graph. So here is the unweighted graph with getPath. So here, this is this where we have we're gonna add the new method. So here we're gonna prompt the user to enter a starting city and enter an ending city. So now apply this graph dot get path. So here's graph get index for the starting city and index for the ending city. And now the path, we have this path in this list. So we can get this or this vertex and using this index here. All right, so here is the one we have. It's from the book, we copy it. So this is the this is the one we're gonna write. So this is the one we copy from the book. It's unweighted graph, and then we copy everything here from the book. We copy the all this this graph interface, and we also copy this edge right here. All right, so we put all this here in this template. Okay, so actually I put this as in the class here. So this is this should be fine. All right, so here, and so how do you write the code for this get path? All right, so I'm gonna give you some hint for this. I'm gonna copy and paste this code right here. So here is the this is exercise 28.5. Okay, so I'm gonna copy here into this. Okay, so this is the one here. We just copied this from the book. It's get path. So we're gonna write the code. So I'm gonna give you some hint on this. All right, so what you need to do is, so it's and get a breadth first search tree, starting from U, starting from U. So here is you're gonna have this search tree is the is is so this one is the you're going to get this search tree. So please note that so this search tree is already defined in this. Here is the it's here, it's in this. So here's it's the right here, the search tree. It's public class search tree, so it's already defined here. Search tree. So we're gonna get the search tree. Okay. So here it's a search tree. Okay. It is already defined the inherited. So because here we have this right here. See, you have this one here's unweighted graph with get pass, so extends unweighted graphs. It's already defined there. So you don't need to have this qualifier, unweighted graph and integer dot. So this is not necessary. So you don't have to put a qualifier here. So this is okay because it's inherited this. So here in book breadth first search, this dot breadth first search with you. Okay, so this is not necessary, but it's okay. Put it here. All right. So now, what you need is you have this tree. So look at the tree here. You're gonna get this you can get the path. So it is from the you can there's a method here in the search tree. So this is search tree. If you go back to look at the search tree here, so here we have the search tree. So where's the search tree? Search tree. So look at the search tree has a method. It's public class search tree right here, search tree. So it has this method and get path. So it returns the path of the vertices from a vertex to the root. So the root is you. So you can use this V to get this path, get the path. So you can get the path there. So get the path. Get the path from V to U in the search tree, in tree. And from here on, and so you can see if, so here is this, if you have this, if there's no path, so the path is empty, there's nothing, so you're gonna return null, and so, and otherwise, and you're gonna return, and this, you have to check this path. See, the path is from this path. I think this path here is from, for this search tree here. So this is search tree. This path here is from the vertex V to U. You may reverse, you need to reverse it from U to V. So because that's that is the definition for this this get path. So get a path from U to V in the tree. Reverse the path. So it starts from U. All right, so then you can return the path. So the path is in a list. So the path is in a list. Okay, return the list. Okay, I'm gonna get a copy of this now. All right, that's all for the hints. If you have any questions, please email me and we can continue to discuss it in the class. Thank you very much. Goodbye.